Hello student, let's try to understand power of lens student. Okay, so if we talk about the power of lens, this is NCERT books only student. You have already learned that ability of lens to converge or diverge. Light ray depends on in focal length. On what factor the ability of light it is depending that is on the focal length of the lens student. Okay, for example, a convex lens short focal length bends the light rays through the large angle by focusing them closer to the optical center. So if you see, this is the convex lens, and here if the parallel beam of light is student coming for the infinity, suppose object is at infinity, so what will after reflection student, it is going to be converge at f2 student. Okay, f2, this is f1 and this is here 2f1, and another light ray is student, this is the infinity object at infinity, this is large size object. So this is the what converging and the principal focus, so very close. So that is what the point they are saying. A convex lens of short focal length, this focal length optical center, and this distance is the focal length, short focal length. So they are saying convex lens of short focal length bends the light rays through larger angle, bends the light rays through larger angle by focusing them closer to the optical center. Now, similarly, concave lens of very short focal length causes higher divergence than the one of the longer focal length student. So, if the same is there, suppose the concave lens, this one. So, if the object is at infinity student, so what there, this is the f2, 2f2, and this is the f1, and this is 2f1. So what it is going to do student, this one, this is diverges, and this is again going to diverge and appears to be coming from the focus. So the point there, similarly concave lens very short focal length causes a higher divergence when the one with the longer focal length. Okay, the degree of convergence or divergence of light rays achieved by the lens is expressed in the term of power. The power of lens is defined at the reciprocal of its focal length. It is represented by the letter P. The power P of the length of focal length F is given by P is equal to 1 by F. This is. So that is the degree of convergence or divergence is studied under the term is called the power of length student. Power of lens. Here you see similar. They are saying the degree of convergence or divergence of light rays achieved by the lens expressed in the power of the lens. The power of lens is defined as the reciprocal of focal length. This is represented by letter P. The power of lens P of focal length F is given by P is equal to 1 by F. So this is the SI unit of power of the lens is diopter. It is denoted by letter capital D. If F is expressed in meter, F should be in the meter. Then power of lens is expressed in the diopter. Thus, 1 diopter is the power of lens whose focal length is 1 meter. 1 diopter is 1 meter inverse. You may note that the power of convex lens is positive, that of the concave lens is negative. So power of convex lens is positive. See, keep in mind, you may note that power of convex lens is positive and that of concave lens is negative. Optician prescribe corrective lenses indicate the power. Let us say that lens prescribed has power plus 2D. This means the lens prescribed is convex lens. The focal length of the lens is 0.5 meter. Similarly, lens is minus 2.5D has focal length minus 0.40 lens, and the lens is concave. So this is all about the answer student. Thank you very much for watching.